yard up here is currently empty. I've shifted all the trains to kind of the other side of the layout, really, because I've got some pretty serious upheaval going on up here. There have been problems up here with the motors, with the wiring. I've had motors at the top really fidgeting, and when the servo motors fidget, it means the micro switches start reporting the wrong state of the turnout, and then JMRI gets involved and tries to put them right when they're not actually wrong, and it all goes a bit bonkers. I don't know why some of these servos fidget. It seems to be some kind of electronic interference that I'll never get to the bottom of. So I decided I was going to have to pull this board up and pretty much swap all the motors out just to try and get some in there that aren't affected by this this weird interference. But then I thought if I was going to pull the board up, there'd been one or two things I'd been thinking of doing anyway, so it would be a good time to start looking at them. It's not particularly visible because I've got trains parked down here out of the way at the minute, but I resisted the temptation to put double slips in on the other side down here. There's a junction there, a crossover, and then a little bit further down there's another crossover that if you go over both of them you kind of get across to the third lane. And I deliberately resisted putting double slips in here because, as I've mentioned before, Pico don't do an electrofrog double slip in code 100. And for the same reason I wasn't going to put a double slip in up here. But then I started thinking that the reason why I was avoiding insul frog stuff was because of the trains, and because I had a lot of old trains. I haven't got any trains at the minute. I had a lot of old trains and they didn't have particularly good pickups, and they were prone to stalling on anything that was insul frog. But I've kind of changed a lot of the trains since then, and most of the trains, certainly all the trains that run on automation, are much more modern and have a lot more pickups on them, so I doubt they would really struggle over those insul frog double slips. And the few trains I've got that are still kind of the old ones, the ones I had when I was a kid, well, they're never going to be running on automation anyway, and to be honest, when I'm running them manually, if one of them stalls up there, then I'll just come and give it a push, and you know, I'd live with that. It's the automation that needs to be reliable, and the only trains that are getting automated are the newer ones. That's given the opportunity then to put these double slips in. The main advantage of the double slips is they just save so much space on a crossover, and it's space I could have done with, because I've mentioned in a previous video that going off down there, there's going to be a kind of a passing loop that needs to have been over with and longer than my longest train by the time it gets just past the trusses there. So I really needed to save space here so that there was enough track running around there for that passing loop to work. In terms of connectivity, I have followed the Pico recommendations of isolating what's left of the frog, these two little rails here, and having their polarity switched by a switch anyway. It still means that there is this plastic connector here, but the polarity is going to switch anyway, which could reduce some short circuits when fat wheels come across here. This, I think, is why Pico recommend isolating the two frog rails from the main double slip, and that's because for people like me who are using these fat Hornby, old-fashioned Hornby wheels, they're so fat that they can quite easily stretch across from one of these rails to another as the train passes over, and as it comes default, these two rails here are different polarity, so any fat wheel that goes over that frog like that is risking causing a short circuit on the layout. And anyone who uses sound, things like that on DCC, it's going to be very inconvenient and noticeable. So by completely isolating these two frog rails here and having them connected and on the same polarity, and that polarity switched in the same way as an electro frog would be. That problem is being removed, or the risk of that problem occurring is being removed, because these two rails will always be the same polarity. So it doesn't matter if a big fat wheel comes and sits across both of them like that. The modifications Pico recommend then are just to snip these two wires. These are the two wires that go from the main double slip into the two frog rails that are just here. So I just took a little pair of snips and snipped the two wires here, twisted, if that's visible, twisted the two frog wires that are coming from these two rails together, and I'll solder a wire to those now. It's worth pointing out as well that I need to be careful with these two wires, because these are separate polarity, so a different polarity, opposite polarity. So I need to make sure that they're tucked back into these little delves here, because if I end up kind of accidentally crossing them over and plant the thing onto the layout with these two wires touching, I'm just going to have a constant short circuit. Here it is all cabled up then, frog cables connected to each other, soldered together and soldered to this green one. I've put droppers on there, absolutely not necessary depending on how you're connected to the rest of the layout, but they're usually not necessary. I've just put them there for redundancy, because if I did end up with a dodgy fish plate, say here, it's going to take so much effort to get this thing in and connected up with connections to 4 bits of track. It would be a pig to get up, so they're just there for redundancy, really. I think I've got both of these double slips settled in. Then there's another one down there somewhere, with the holes drilled, cables set through them. I always struggle bringing them up with all those cables dangling down from underneath. I always struggle to measure out where to drill the holes for the cables. So what I've started doing is just getting one that doesn't have any cables, planting it there before this one goes down, and using that one to mark just with pencil through where my drill holes need to be. Drill the holes, then put the one that's actually going on there on, and pull the cables through. I've got quite a bit of thinking to do here then, I think. So the general idea, these bits of track are just placed for the general idea of how it's going to be. This bottom one here will be the inside line, that'll be the anti-clockwise, so stuff's going to be going this direction. This is the clockwise main line, so it's going to be going in this direction. The line above it here is kind of like an access line to help swap trains between the two layers, just to give me a bit of a passing loop, I guess. But it will be a loop in itself, and it will go into the station. So maybe the kind of idea is there's an anti-clockwise train going this way, there's a clockwise train going this way. Something can come up from the storage lines below, get itself on this access line, get itself around to the station, and then at the same time another train can then cross over and go back down again. My main concern really with these double slips is block occupancy, because the double slip is pretty much going to have to be its own block. It can't extend this way, because then if there's any train on this bit of track here, it's going to occupy the double slip as well, and can't have that because there might be something here parked waiting for something else to go down from the clockwise line. So I really am going to have a very short piece of track as a block. The concern there, of course, being occupancy and coaches, wheel sets that don't draw power. So it's starting to look like I'm going to need at least a resistive wheel set on every coach, maybe even on every bogie, which feels excessive. So I'm definitely going to, my first attempt, I think, with this, when it's all wired up, will be to put a bit of a delay to inactive on the current detector that will eventually be under that, just to give anything that's not actually providing any resistance, drawing any current, a chance to get over, and then something else that might be drawing current at the end to get over as well, just to keep it occupied. So now with these two double slips installed on this board runs from there over to here, so I just need to get at least the track around them screwed down so they don't move too much, and then I'm going to have to pull this board up, flip it upside down, and see if I can get the mounts and the motors fitted and the ones at the back replaced. Here's the upside down board with the motors attached then. They're all attached pretty securely, and I'm pretty certain that the piano wire has gone through the tie bar, but now it's just a case of flipping the board over, making sure that the tie bar is moving freely, and then get the servos connected up and calibrated. I do keep a stock of piano wire. It's really quite cheap off eBay. I think this has had a couple of arms cut off it already, but it was only about £5. This is 1mm, which seems to work about perfectly with the tie bar, and it just means that the Merg mounts come with piano wire, but they come with exactly how much you'll need. And I like to have quite a little bit of spare sticking up through the tie bar, so I can lift the points up and down and adjust them when I'm connecting them to other bits of track. I think I have these aligned now, so it's just a case of one more run through for each of them. So I've got a keyboard here just to make my life a bit easier. I just really want to check that there's a smooth line, that the blade is fully against the rail here, so that wheels don't get trapped, and that's looking good. And then 2000, looking good. And then on to the next one, which is 19, and let's go 100x. It's a noisy one. But we're good and tight. Something that struck me is with the new servo motors going on those new double slips up there, I'm going to run out of capacity on this side of the layout for servo motors on those PCA9685 boards. I've got one board, that's the second in a chain there, and there's another one a bit further down there, and then we're about in the middle here. This is where the servos are, and then there's another board down there. But I was already at full capacity pretty much, so I need to start thinking about how I'm going to increase the capacity for the additional servos. I do now have an ESP32 board along this side, which is connecting to Wi-Fi and MQTT, and currently just sending a few sensor readings back from the micro switches up there. I wanted to shorten the sensor cables and not send them all the way back to an Arduino. And these ESP32 boards do have 16 PWM channels on board, which is the same as one of those PCA9685 boards. So this will give me the capacity to run 16 more servo motors down here without any more boards or anything like that. The only drawback to that is that I will also need to drive relays for them still, because I need to switch the polarity of them still. And the servos will plug in quite easily into these boards. The PWM goes into one of the pins there, and then there is a 5-volt little board up there, so the positive and negative would just go into there, and that would get the servos moving okay. I've just got to think a little bit about the relays. The way I've got these relays wired up here is far from ideal. It was kind of one of the first things I thought of when I first set this layout up, and it really came from some laziness and a lack of understanding, I guess, and not knowing how to do it any differently. And what I did was, with these PCA 9685 boards, I essentially split them into two. They've got 16 channels on them, And what I decided I would do is I'd use the first 8 for PWM and the second 8 to drive the relays, because that meant I could drag a 5-volt supply from the board into the relay as well. It works, it's just wasteful of these little boards here, really. So I've decided I'm going to stop doing that, at least down this side now. I'm going to take the relay off these PCA 9685 boards and have the relay driven completely independently of everything else. I'm used to working with CMRI, and with CMRI you had nodes, and an Arduino was a node, and it kind of had everything you needed connected to it, and that was how you addressed everything in CMRI. But I now use MQTT, and MQTT doesn't have a concept of nodes. It's more a case of having little pop-up controllers all over the place, and all they need to do is communicate with MQTT, and JMRI won't care where they are, what they're connected to, whether they're on Wi-Fi or Ethernet. They are just they just send and receive messages and act upon those messages like everything else. So whereas with the Arduinos, I tended to have a board that would do everything in the area it was in. So this one has a relay, it has a PCA 9685 board, it's connected to lots of sensors and does everything. It reads the sensors, it drives the turnouts, it drives the relay and the polarity and everything like that. But I don't need to be as rigid about these rules now. So what I'm going to try with the relays is I'm going to completely isolate them on their own board, probably using shift out registers, and just potentially have one board running all relays and none of these existing nodes caring at all about relays. With all the motors in place and wired up, I've got this little configuration sketch that just allows me to go through, set PWM values for each servo so I can work out what the 2 extremes of movement need to be for each of the servos. And as I've gone through that, I've made a note here of what those values were and which pin those motors were on for the 6 servos, and there were 2 that I've marked there that needed adjustment because I couldn't move them to extremes, probably I'm assuming because the micro switches wouldn't allow the full movement. So next is to examine it all from underneath. Just a close up here then, and now the board's upside down. I can move the servo with the same values I was moving when it was the right way around, when I knew that the 2 extremes had the blade where I wanted them, and I can just make sure that the switch gets pressed when the arm is close to it. I must admit, I had hoped in swapping from those PCA 9685 boards to actually using the ESP32 boards for PWM control, that I might finally eliminate all of the buzzing and fidgeting that I was getting from some of these servo motors, not all of them. But it turns out I haven't. So if I demonstrate that by just moving this motor here, there's a very quietly audible buzz there, but if I move it back to its original position, we've got a much more noticeable buzz. Now, I don't like these buzzes for a couple of reasons. First of all, they're noisy, but second of all, I think they indicate that the motor is trying to do something that it's physically unable to do. It's trying to move to a position that it's being prevented from moving to. Because if I switch the channel to another motor, the buzzing immediately stops. So the way it worked with these boards was the PCA 9685 board, the one on the left there, has 3 pins on it for each motor. 2 of them are ground and 5 volt, and the third one is PWM, and that's what delivers the PWM value. And the way the Adafruit library works is the motor's got power all the time, and the PWM value is constantly sent down the PWM cable, so the motor is always powered and always working. Even if it's in the position it needs to be in, it's using power to stay in the position it's in, and that's why it's quite noticeable with those motors that when they're not powered, when they're not connected, or when this board isn't switched on, you can physically move the arm on the motor, but when it's all powered on and working, you can't. It's absolutely stiff, and that's because the motor is consuming power all the time, and it's acting on that PWM value even if it doesn't change. And by default, that's pretty much the same on these boards as well, and that's why this thing's buzzing. It's probably trying to get, again, to a position it can't physically get to, because I don't think it's a problem with the motors. The motors don't make that buzzing noise when they're on the workbench, and they've got absolute freedom of movement. They're not attached to anything. But it does worry me that the motors and the more they're unable to move to the position that they want to get into, the more likely they are to overheat and melt, basically. But something the PWM library for this board has, because I had to switch, I couldn't use the Adafruit library on these because it's a different set of hardware and different set of doing things, different way of doing things. But the library for these ESP32 boards, I think, as well as the Arduino, because the Arduinos themselves have maybe, is it 5 PWM pins on them? Anyway, the library for these boards has a detach command on it, and what that means is when the code has moved the arm to the position that it needs to be in, it's detected that it needs to move and it's moved it, I can then detach the PWM channel from that servo. And what that effectively means is the servo switches off. It's moved to the position that it needs to be in, and rather than constantly consuming its 5 volt supply and actively maintaining its position, it just moves and it switches off. And it means that the arm could be physically moved again, and it's not rigidly staying in position, but it's stiff enough, I think, to stay where it was sent to and maintain that position until it receives any further instructions. What I've done then, and this is just the sketch that I wrote that does the configuration of them and gets them into the right positions. What I've done is, after writing the microseconds of the PWM value to the motor, there is a delay of 200 microseconds. That's just a lazy way because it doesn't really matter in this sketch, but what I have to make sure of at this point is that the arm has got to the position that it needs to be in before it's detached. I can't just send the value and detach instantly, or it simply won't. It'll stop as soon as it receives the detach and it won't get to the position it's in. So those 200 microseconds just allow the arm to whiz into the position it needs to be in, and then this line underneath the if one just says, okay, well, if it is attached, let's detach it now, and that effectively turns it off and leaves it absolutely dormant until it is next needed. I can't use that delay in my main sketch. I'm gonna have to do something a bit cleverer than that, but it doesn't matter here because the sketch isn't doing anything else, isn't needed to be doing anything else while that delay is happening. Back here then on the set of points, and I'm going to move it again. This time we've got the detach in the sketch, and the thing's still moving. It's still staying where it's supposed to stay, but as soon as it gets there, the detach happens and it gets switched off, and there's therefore no buzzing. It's just absolutely silent. I think it's strong enough, stiff enough to stay where it is and not get budged. I'm hoping another advantage that it'll bring is, for some reason, there's a couple of motors around the layout. There was one up here and there's one on the other side as well that really suffered from electronic interference, and the way it manifested itself was really weird. Say if it was this one, there'd be another set of points way down there somewhere, and every time the APT in particular went over the frog on a set of points way down there, even though they were on different boards and different power supplies, the servo over here would fidget like crazy, and fidget enough to release the micro switch, which would then send a message to JMRI to say that the points have moved when they shouldn't have. JMRI would try and react and fix it, and the whole thing went crazy, and you'd end up with short circuits because frogs weren't set as they should be, or you'd have a point blade moving, like JMRI arguing with the sensor and that kind of thing. And I never got to the bottom of what caused that electronic interference, but I'm hoping that by detaching these things, effectively switching them off when they move, then there is no active PWM signal going to this motor. It's therefore not listening and reacting to anything, so it doesn't matter what happens anywhere else on the layout because the motor is effectively switched off, so it has nothing to react to, and isn't going to do all that silly fidgeting. When I finally got more track laid down and connected up to this board in the middle, I'm really going to find it very difficult to pull this board up again. There's going to be so many connections through points and double slips and that kind of thing that I'm really never going to want to pull this board up again. So with that in mind, I've adapted the sketch that I wrote that does the test and calibration of the servos through the ESP32 board to also monitor the pins that have the micro switch sensors on them, so that once I get to this point and I'm say if I set my motor to pin 18 and then I set its PWM value and it moves, it's telling me, as well as that it moved, it's telling me that the sensor on pin 16, so immediately I know which pin on the ESP32 the micro switch is connected to, and it's telling me that it changed value. So what I'd hope is I go back to this, and when it releases or when it hits, whichever one it is, there's a little bit of debounce that I might try and sort out, but that's not a huge amount, and it's pretty consistent with it as well. But what that's doing for each one, if I change it to pin 19 and the next board along and give that a value of, what's that, 1900, and then seeing that on the next one along I've got a sensor on pin 14, and all this code I'll share in the usual place and put links to in case anyone wants to look at it. A couple of other little issues and fixes that I've come across while I've been working on this board as well. I was having all kinds of problems with this Arduino here. It was overheating, it was short circuiting, and I think actually one of them fried and I had to replace them. It pretty much came down to this Ethernet board. I don't know why, but when it was connected to the ICSP header here, it was causing some kind of electrical issue that I never quite got to the bottom of, but the Arduino really didn't like that board being connected to those headers there, so I shifted them and simply put them back on those 51, 52, 53, whatever they are, and the board has been much happier since. When I did that, I was still having issues with this board that were unrelated. The board would reset itself. Maybe I'd turn it on and it would maybe run for 30-40 seconds, but then after that it was resetting itself every 5 seconds. And the issue that I think that was because what I've done to fix it, seems to have fixed it, was that there was too much voltage demand, too much power demand coming from all these wires going to these current detectors and everything else like that. So like I've done in the other corner, I put a separate 5-volt power supply into the power supply on the sensor shield itself and pulled the pin, the jumper thing that was was connecting those two pins off. So now the Arduino underneath is powered by this 12-volt supply, and that's pretty much it. It doesn't have any demand on it. And then the sensor shield that's on the top, all of the 5-volt headers that are along here that all these things are connected to, are being fed by these cables here, which is an independent 5-volt power supply. And the board has been much happier since then. Another issue that I was having, this all needs, like everything else, needs tidying up, but this is effectively a run of 5-volt power supplies, of 5-volt pins. So it comes from the same 5-volt power supply that I was just pointing at before. Got 2 rows of pins soldered onto this board, and the pins are underneath, connected by just a bit of solid core wire that runs right across and solders to each pin, and so it becomes a row of 5-volt headers effectively. Now what I was doing, these chain along with all of the shift registers and everything else, so that there are 5-volt headers wherever I need them. There'll be another one, I think, is it against the that one's actually fastened up over there, and I was connecting them with these, which I bought quite lazily off eBay, which are just very long DuPont cables, because I couldn't be bothered to crimp cables. But that was a mistake, because these cables can't carry 5 volts, it turns out. I was having problems. That, again, the way this issue surfaced was I was getting nonsense on these chains of shift in registers. The first one worked okay, and then the second one was just, as soon as it got connected, there was just nonsense being fed into the Arduino all the time. 0 1 0 1 0 1 on all the pins, and nothing sensible. And I think what it was because the second shift in register is connected to the second power board in the chain, and they were connected, the two power boards were connected by these rubbish cables. These cables couldn't carry 5 volts, so I ended up taking a multimeter to it, and the first it started at about 4.9 volts at the power supply. This one was down to about 4.1, and then the next one along was down in the 3s. So these boards weren't weren't getting enough power. So I have been less lazy now, and I've connected these boards up using dropper wire that I've crimped the DuPont headers onto, and now I'm getting 5 volts all the way along the chain, which it is much more stable and has fixed the issue with the shifting registers as well. All in all then, and finally, I seem to have got past all of the issues that I was having down this side, particularly up there, and it is a bit of a relief, and it's taken me over a month to get through all these issues and work out what the cause of them was. So now moving forward, I need to get the track all connected up again up at the top, get the piano wires cut so that I can start testing the track, just running coaches over all of that new track, the double slips, and make sure that I'm not getting any derailments as stuff goes up or heads down the hill. I've still got to connect up all of the frog stuff, the new way I'm going to do electro frog, that all needs doing, but I feel like at least I'm at the end of all of the issues. And it has, I mean, it's been massive upheaval, because everything had to come out of here from underneath the layouts I could get at the wires as well. The place is an absolute tip. All of the trains are kind of over that side and parked up. Nothing's run for over a month. So I'm really hoping that while I'm testing this and now the board's in and I'm happy with it, I can bring the trains back round, actually start bringing running trains again, because I've got 3 new ones that need running in downstairs that haven't even touched the layout yet. So I'm hoping now I'm gonna get back to normal, be able to run trains, and then start extending the track and finally get a top layer running as well.